Presentation layer contains the UI in the form of widgets and also the presentation logic holders, which can be implemented as a ChangeNotifier, Bloc, Reducer, ViewModel, MobX Store, you name it. In the case of our number trivia app though, we are going to use the Flutter Bloc package to help us with implementing the block pattern. Hello, welcome to ResoCoder, where you are getting prepared for real app development by building better, faster, more stable apps. So subscribe and hit the bell if you want to grow your coding skills. So now we have the whole data layer implemented. In the last part we finished with the number trivia remote data source, and now comes the time to create the files needed for the block, which will go into the presentation layer. But before creating the files and classes needed for the block, it's a wise idea to hand over the repetitive work of creating all of those files over to some extensions in the case of VS Code, or plugins in the case of IntelliJ or Android Studio. And be sure to check out the written tutorial from the link in the description, where you can also find all of the code written in this video, links to the libraries, links to the extensions, and also go through this lesson at your own pace. So we want to search for block and just make sure that this is installed. The first one, not the second one. I don't know what that even is, but the first one from Felix Angelov, this you should have installed. And also, if you want to find out which extensions you should definitely have as a Flutter developer, check out the video from the card in the corner. In addition to adding the option to create new block files in just a few clicks, this extension also adds a bunch of code snippets which you can use. So definitely that's also a good thing about this extension. Let's now move on and create new block files inside the presentation folder. Actually, we now currently have the block folder, which is empty inside the presentation folder, but we are going to delete it because it's gonna get created by the block extension. So let's just delete the block folder, move to trash, yes. And we're going to right click on presentation and select block, new block. We're going to give it a name. In our case, it's gonna be called number_trivia, all in lowercase, of course, and we're going to select that we do want to use equatable, and it's going to create a new block folder with 4 files: number trivia block, event, state, and also an export barrel file, which simply exports all of the 3 other files. Let's go through the concepts of block bit by bit. Block is an abbreviation for business logic component, and following the clean architecture, it should actually be called PLOC, so presentation logic component, but I just think that we are going to stick with the official abbreviation. But really, inside clean architecture, all of the domain, the business logic, is already contained inside the domain layer. So the block will in fact hold only some presentation logic of transforming the input data and all of that kind of stuff. Now, if you are completely unfamiliar with block, you should definitely check out the video from the card in the corner for full in-depth explanation. Right now, I'm just going to explain the block in a nutshell. It is a reactive state management pattern, which means that the data flows only in one direction. And the flow of data can be separated into 3 core steps. Signified by the schematic, it looks like this. Events are dispatched from the UI widgets, and they arrive inside the block. The block receives events and executes some appropriate business logic. In the case of clean architecture, it's just going to call a use case. And then, once the use case spits out some data, that data will be put into a state, and that state will be emitted from the block back to the UI widgets, which will do something useful with that state and the data contained inside the state, and they will display something nice to the user on the screen. Events can be, for example, something like get concrete number trivia or get random number trivia in the case of our number trivia app. And the events are dispatched whenever, for example, a button is clicked, or whenever a text is entered, or whenever a user does some action. Usually that's when you dispatch events. If we take a look at the number trivia event.dart file, currently it contains only a single base abstract class, which extends equatable, which is definitely a good thing. So as I've already briefly outlined, our app will have two events. Those events will be dispatched from the widgets. If we take a look at the UI, how it will look like, we can see that we really have just two buttons which can dispatch events. And those buttons are for showing trivia for a concrete number, the search button that is, and then another button is for a random number. So those events will be get trivia for concrete number and get trivia for random number, and they will be dispatched whenever the button is clicked. And I know that inside the repository and inside the remote data source, we've been implementing the random and concrete cases of getting the data very similarly, but this time inside the block with these two events, there will actually be some difference in their implementation, and it will not just be changing one part of the string. It will be actually quite a profound difference that there will be. So we're going to have some fun while implementing that, but let's just for now create two classes for those events. The first one will be get trivia for concrete number. And of course, it's going to extend number trivia event, and it will have one final property, which will be of type string, and it will be the number string. Now, you may be wondering, why are we not passing around an integer, since it's for getting a concrete number, and everywhere else we are passing around integers, not strings representing integers? Well, that's because the number string will be taken right from the text field from the UI widget. And a value held inside the text field is always a string. It's never going to be an integer. And the reason why this event will hold a string is because converting a string to an integer directly inside the UI, so inside the widgets, or even inside this event class, because if we really wanted to, we could create final, I don't know, maybe int number, which would simply, or it would be actually a getter, so int get number, which would simply get int.parse number string, right? We could do that, sure, but this is a presentation logic. And this would go against everything what we were trying to accomplish by implementing clean architecture. Because clean architecture is all about maintainability, readability, and testability. Oh, and also, just by the way, we would violate the solid principles, more precisely the first one, which is the principle of single responsibility. Because events should not be converting data. Events should be just passing data to the block. And if we were to put this conversion logic into the UI widgets, we would also violate single responsibility principle, because UI Flutter widgets should only display data and dispatch events. They should not have any presentation logic inside of them, even as simple presentation logic as this one of parsing an integer. And also, if we would want to expand on this so that we will actually have some limitations, that the integer cannot be negative, for example, which we are going to do in this tutorial, in this part, like this business logic, which is now simple, would get more and more elaborate. And also, this can throw an exception, right? So what's going to happen then? How are we going to handle it? That's why it's absolutely crucial to never put any kind of logic inside classes where it doesn't belong. And that goes most definitely for the UI widgets and also for something like events. Follow the single responsibility principle and you'll be good to go. And in Flutter, this is absolutely necessary because, as you know, UI is written in the same language as the logic is written in Dart. So it's really easy to put logic throughout your UI widgets. But by doing that, you get rid of any benefits which the clean architecture and test-driven development provide. So I hope I have scared you enough. So let's add another event here, which will be get trivia for random number. And then we are going to move on to input conversion. So random. And this will not contain any fields because it's for a random number. As I've said, we're now going to create the input converter for this number string, which will convert the string to an integer, and it will also provide some limitations as to, for example, that the string cannot be representing a negative number. We're going to create it under the core folder. Let's create a new folder here called util. So it's nested under core, and we're going to create a new file under that called input converter. .dart. And of course, this is holding presentation logic, so you could also just create another subfolder under core called presentation and move that util folder under presentation, but I think we are just cool without this deep nesting. We're gonna break our tradition a bit and create a class for doing the conversion without first creating an abstract class contract, as we are used to by now. Personally, I feel that creating contracts for simple utility classes is an overkill, so we can just create a class input converter, and we are still gonna be able to easily mock this input converter because every class in Dart exposes its interface, and every class can be implemented as an interface, so the mock creation will not be a problem. We're gonna, of course, mock this input converter inside the test for the block, which we are going to implement in the next part. The purpose of this input converter is actually very similar to the purpose of the model, because just like the model, if I could find it right here, just like the model is responsible for shielding the domain layer from the influence of remote APIs and from JSON, the input converter will in the very much same way shield the domain layer from the influence of input conversion, because the domain layer should not care that the text input field only operates with strings. When something is a number, it should be an integer, not a string. The domain layer should not care. And the domain layer not caring is precisely possible because of these kinds of conversion classes which live on the edge between layers. The model lives inside the data layer, and this input converter lives inside the presentation layer. Of course, it's inside the core folder because it can be possibly shared between multiple features of the app. So, enough talking. This will have one method returning an either type, because either is amazing, which will hold failure, of course. And in the case of success, it's going to return int. And let's call this method string to unsigned integer, which will accept a string, str we are going to call it, and let's just put a to-do comment over here. Let's import failure, let's import darts for the either type, and the failure which we are going to return whenever something goes wrong will be invalid input failure. Of course, it's going to extend failure. Oh, and also, just now I have realized that because we are extending number trivia event from the get trivia for concrete number event, we need to also pass the property to the super constructor in order for the equatable to work properly. So let's pass number string over to the super constructor inside a list, of course. Now we are talking. All right. Let's move back to input converter. Just like any other class which contains some logic, we're going to create a test for the input converter. So let's create a new file under test core. Let's create a new folder, util. And inside of here, we're going to create a new file called input converter test.dart. And let's just import darts. Then also Flutter test.dart, and inside the void main, we're just now going to set up the test, of course. We are not mocking anything because the input converter is probably the only class inside, or one of the only classes inside this project, which does not have any dependencies. So we want to have an instance of input converter. Call it input converter. Let's import input converter class. And now inside the setup, we are simply going to instantiate the input converter and pass it over to, or actually store it inside the variable. And while we are at it, let's also create the first test. It will be for the string to unsigned int method. So we are going to create a group, string to unsigned int. And inside that, we're going to have arrange, act, assert, test. This method should return an integer when the string represents an unsigned integer. So this is the case when everything goes smooth as butter. So we should return an integer when the string represents an unsigned integer. And of course, inside the arrange, we're just going to create a string here. Final str is equal to something which is a valid positive, so unsigned integer, for example, 1, 2, 3. Inside the act phase, we are of course going to store the result of the call to string to unsigned integer. So input converter that string to unsigned integer and pass in the string. And then we will expect, of course, that the result is equal to not just 1, 2, 3, but instead to write 1, 2, 3, because that method returns an either, and when everything goes successful, it should be the right side of either, which means success. Because if something goes wrong, if the string is, for example, negative, or if it contains some letters, we're going to return failure on the left side of either. So of course, once we run this test, it's going to fail, as always doing test-driven development, but we don't need to be sad because we can now fix this implementation so that the test will pass. So inside here, removing the to-do comment, we are just going to return write and wrap the int.parse and parse the str string. Because again, we are implementing only the least amount of functionality in order for the test to pass. And this should make the test to pass, I think, because everything goes smoothly, right? But of course, not everything will always go smoothly. The string can contain letters, or the string can contain a decimal place. And of course, a number with a decimal place is not an integer, so even when something like 1.05 is passed into the int.parse method, it's going to throw an exception. So we need to handle that and return an invalid input failure. So let's move on to another test. The next test should return a failure when the string is not an integer. So let's just actually copy the code from the above test, but instead of the string being 1, 2, 3, it's going to be ABC. But this is the same case if this were 1.0, because int.parse method, which is implemented in the Dart language, I think, will just throw the same exception as if the string were ABC. So it doesn't really matter. And now we will expect that the result is the left side of either, which will contain invalid input failure. So if we now try to run the test, it's going to fail. And what actually happens whenever an invalid string is parsed in the parse method? Whenever this thing happens, a format exception is thrown. So what we need to do here is to wrap this code inside try catch. And we are not going to catch any particular exception, or actually we are, but we are just not going to store it inside a variable. So on format exception, whenever this exception happens, after calling parse, we are going to return left containing the invalid input failure. Now when we run the test once more, it should pass, and it does, so that's cool. But this is not everything which we want to do inside the input converter. Because while the API can in fact work with negative numbers, it's just always, at least for now, going to return that the number was not found. So it doesn't return any error status codes, it still responds with 200 success status code, but it doesn't give us any meaningful data for the number trivia. So that's why we're going to limit the range of numbers to be only positive integers. Let's first create a test then. We are again going to basically copy the whole previous test, and now it's gonna say that it should return a failure when the string is a negative integer. So now when it's minus 123, 123 of course, and we call string to unsigned integer, it should still respond or return left side of either with invalid input failure. So how are we going to implement that? And of course, when we run it, it's going to fail as usual. And the way to implement it is of course very simple. Inside the try block, we're just going to store the result of int.parse in an intermediary value. So final integer is gonna be equal to int.parse the string. And of course, if integer is less than 0, we're going to throw format exception. Of course, we could just return left invalid input failure right from here. That's also possible to do, of course. But since we are already returning left invalid input failure whenever a format exception happens, we're going to throw format exception, which will be caught immediately down in this catch block. We are doing this because if the exception handling was more elaborate, if we were doing something more than just returning left containing invalid input failure, this way we wouldn't need to duplicate that more elaborate code in two different places. And now, of course, when the exception is not thrown, we are going to return right, wrapping the integer which was parsed. So in this case, we know that the integer will never be negative, because in such case we're going to return a failure. So now when we run this code, it's of course going to pass. We are going to use this input converter as a dependency inside the block right here, which we are going to implement doing test-driven development in the next part. Let's now take a look at the states which will be outputted from the block, and the states will hold the data to which the UI will react and show something nice to the user. For example, it will show the loading indicator or the actual number trivia. So inside number trivia state.dart, we currently have only initial number trivia state. We're actually going to rename this, so hit F2, and we're going to rename this to empty, because that's what it is. It represents that no trivia is displayed. Then we also want to have a loading state to which the UI will react by displaying a circular loading indicator. And these two states are completely empty because they do not need to hold any data. And now we're getting to the interesting stuff. The next state should be loaded, which will actually hold a field, because whenever a number trivia is loaded, it should hold the number trivia entity. So final number trivia. Let's import number trivia. Let's just call it trivia and import it here. And let's create a constructor, but it will be wrapped inside two curly braces to make it optional named, but let's also make it required. And we mustn't forget to pass the trivia property over to the super constructor inside a list, because we are implementing equatable from the base class. So this will make it equatable by value equality and not just by referential equality. And then finally, let's just copy this loaded state. And then we also want to have an error state. This error state will be emitted from the block whenever some failure happens. For example, if the user inputs an invalid input, like -123 or ABC, this invalid input failure will trigger the block to output the error state, which of course should contain a string containing the error message, which will tell the user what went wrong. This will also be triggered whenever the cache exception happens, and then the cache failure is returned from the repository, which subsequently is returned from the use case. Of course, we are chaining these calls. We are of course going to get to that in the next part, so definitely stay tuned for that. But basically, whenever something wrong happens, this error state will be emitted to the UI. So this will get the message passed in to the constructor, and also we're going to pass the message into the super constructor. And that's basically it for the states. We're going to have just 4 of them: empty, loading, loaded, and error. Alright, so we've created the events and states for the block together with the input converter, which contains the presentation logic for converting a string to an integer. And hopefully I have also completely scared you from ever putting some business or presentation logic into widgets or even into some classes where it does not belong. And to go through this tutorial at your own pace once again and to get all the code, check out the written tutorial available from the link in the description. In the next part, of course, we're going to implement the block. This means that we're gonna do test-driven development with streams, because that's what block pattern is built on top of. So it's definitely going to be very, very interesting. And if you do not want to miss that part and also more tutorials like this, definitely subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best app development tutorials and resources out there. If this video helped you with setting up the block and hopefully with understanding the basics of the block pattern, if you are not familiar with that, give this video a like and also share it with other developers who will surely benefit from it too. Leave a comment if you have anything to say, any suggestions or questions. Follow me on Instagram, I go under the name ResoCoder everywhere, and see you in the next video.